Hey guys, so this next section, 10.6, is about something called the secant. It also involves tangents. So there's different ways that secants and tangents intersect. So this one does kind of have a lot of rules that we're going to learn, but once you do the examples, it's pretty easy. All right, let's get started. Okay, so first of all, let's define a secant. A secant is a line. It could also be like a segment or ray or something like that, but a line that intersects a circle in exactly 2 points. So notice this PQ here intersects the circle at P and Q. So line PQ would be considered a secant. Now, there are several ways that secants and tangents can intersect. The first thing we're going to talk about is when you have intersections on or in the circle. So on or inside the circle. Now, we're going to talk about 2 secants to start. The first theorem says that if 2 secants intersect inside the circle, the measure of the angle formed, so this angle that we're referring to here is this angle or this angle, which they're vertical, so it's the same, is half the sum of the measure of the intercepted arcs. So let me zoom in on this picture a little bit. So notice these 2 secants are intersecting the circle at P, R, S, and Q. So see P, R, and SQ, those would be considered the intercepted arcs for these 2 secants intersecting. So if you add PR and SQ and divide by 2, you would get angle 1. This would also work, let me show you on the other side, with the other arcs. So like PS this way and RQ this way, those could also be intercepted arcs for this angle. So if I added PS and RQ and divided by 2, I would get that angle. All right, so let's do a couple examples. This first one, find the measure of angle 1. So this is pretty straightforward. We have these 2 secants intersecting. They create this arc that's 40 degrees, this arc that's 52 degrees, and we're trying to find angle 1. So you're just going to add 40 and 52 and divide by 2, and that will give you measure of angle 1. So that's going to be 92 over 2, which would give us 46 degrees for measure of angle 1. So that's a pretty straightforward one. Example 2, you have to take it one step further, but still same idea. These are secants. Even though they don't go all the way through, they're segments. They're technically chords, but they're also considered to be secants. So these 2 secants create this arc and this arc. And so we can find these angles. So we can do 90 plus 130 and divide by 2. 90 plus 130 would be 220. Divided by 2 would be 110. And so this one's 110 and this one's 110. We're being asked to find angle 5. So notice these 2 are a linear pair. So you're just going to do 180 minus 110 to get that the measure of angle 5 is 70 degrees. So sometimes you might have to take it one step further. Okay, the next theorem talks about when you have a secant and a tangent. So if you have a secant and a tangent that are intersecting at the point of tangency, so a secant and a tangent intersecting at the point of tangency. So notice this tangent rather here, T is the point of tangency, and then we have this secant here. They intersect at T, the point of tangency. The measure of each angle formed is half the measure of its arc. So I'm going to zoom in on just this picture for a second and kind of explain what this is saying. So again, I'll highlight the lines. So here's our tangent. Here's our secant. I'm going to use some different colors here. So notice on the right-hand side of this secant, we have angle YTV. Angle YTV is half the measure of arc TV. See this arc that's formed? So angle YTV is half of arc TV. And then we have the same situation on the other side. We have angle XTV, would be this angle, and that's going to be half the measure of this arc. So arc VUT. So see how on either side of the secant, we have an angle with its arc. Same thing on this side, the angle with the arc. And again, the angle is half the measure of the arc. So we're going to do a few examples here. See example 3 here. We have this tangent. We have this secant. Notice this angle is formed. So this angle 3 is half the measure of the arc. So you're just going to do 220 divided by 2 to get that. It's 110 for measure of angle 3. Again, so that's a straightforward one. Example 4, we have to do just a little bit more. So notice in number 4, we're asked to find angle 6. So angle 6 is formed with this secant and this tangent. Here's angle 6. It's half the measure of that arc, which we don't know the measure of, but we can find the measure of it because notice that this 160-degree arc and this arc that we're looking for together make a full circle. So if we do 360 minus 160, we get that this arc here, this side, is 200. So that arc is the one that corresponds to angle 6, which we're trying to find. So if we cut 200 in half, we get that the measure of angle 6 is 100 degrees. Okay, so that's that theorem. So these two theorems, again, are what happens when you have either two secants intersecting inside the circle, that was the top one, or a secant and a tangent intersecting at the point of tangency. The last relationship that we're going to talk about, there's 3 scenarios that this can happen. This is when you have an intersection outside of the circle. So if you have intersections outside of the circle, there's an angle that's formed outside of the circle. So see in the 3 scenarios, there's angle P, angle Q, angle R. This is the angle that we're referring to. So that angle that's outside of the circle is 1/2 the difference of the arcs. So there are 3 scenarios that this can happen. Let me zoom in a little bit here. You can have 2 secants that intersect outside the circle. And so see the 2, let me use a different color. See the 2 arcs. We have BE and AD. So if we were to subtract these 2 arcs, you always want to do the bigger one minus the smaller one. Or if you do the small one minus the big one, you're just taking the positive difference. It says that in the theorem. We don't want any negative numbers here. But if I were to subtract BE and AD and cut it in half, I would get angle P. Okay, so that's 2 secants. Another way you can have it is you can have a secant and a tangent. So here's our secant, here's our tangent. They're intersecting outside the circle at Q. So let's take a look at the 2 arcs. We have GJ is one arc, and then GH is the other arc. So if I were to subtract those 2 arcs and divide by 2, I would get angle Q. And then the last scenario is if you have 2 tangents. So again, notice we have our 2 tangents intersecting outside that circle. Here are the points of tangency. So there are 2 arcs that are created. There's MTN, and then there's MN. Notice that in this scenario, the 2 arcs that are created, they do add to 360, so that will come into play after. But again, if I took MTN and subtracted MN divided by 2, I would get angle R. Okay, so I'm going to do a few examples. Okay, so example 5, we have 2 secants here intersecting outside the circle, creating angle 1. So angle 1 is going to be half the difference of these 2 arcs. So we're going to do 80 minus 40 and divide by 2, and that will give us angle 1. So that's going to be 40 divided by 2, which is 20 degrees. Pretty straightforward. Next one. Next one, we have a secant and a tangent. So here's my secant. Here, oh, geez. Here's my secant. Okay, I don't know why that's not tracing properly, but there's my tangent. They intersect outside the circle, creating angle 2. So let's take a look at the 2 arcs. We have this arc here that's 160, this arc here that's 80. So again, if we subtract those, 160 minus 80 and divide by 2, that will give us angle 2. So that's going to be 80 divided by 2, which is 40 degrees. Okay, so that's a secant and a tangent intersecting outside the circle. The last two examples are both involving two tangents intersecting outside the circle. So those examples, there's a few different kinds you can have. So let's do this first one. We're asked to find angle 3. So again, this is two tangents intersecting outside the circle. Angle 3 is formed by those two tangents intersecting. There are two arcs that are created. There's this arc here. This arc here, that's 220. And then this arc here, which we don't know. So it would be this arc minus the one we don't know divided by 2 would give us angle 3. So rather than set up an equation, we have to find this arc first. Now remember when I was going over the theorem, I said, notice that these two arcs together create a full circle. So we can find this one by doing 360 minus 220, which would be 140. So that means, let me erase some of this, it's getting kind of messy. So that would mean that this one here is 140. So now that I know that one, now I can use the theorem. So I can do 220 minus 140 divided by 2, and that would give me the measure of angle 3. So that's going to be 80 over 2 equals measure of angle 3, which ends up being 40 again. So that's just a coincidence here, but angle 3 would be 40. Okay, our last example is one where you don't know either of the arcs. So I used to always do this one using a system of equations, which I can show you guys if you're interested. But then one year, a student came up with this method, and this is how I teach it now. It's pretty simple. The only thing that you have to do first is you have to connect the center to each of these points of tangencies to add in radii. So you first need to draw in the radii. And the reason why we do that, remember that all radii are congruent in a circle, right? So these are equal. We also learned that when you have two tangents intersecting outside of a circle, that the segments are congruent. So this creates a kite. And so the reason why this is helpful is if you remember these angles in a kite, this one here and this one here, are supplementary. So we draw in the radii to create a kite. And then the angles are supplementary. They add to 180. So what we're going to do is 180 minus 50 to give us 130. So that means this angle here is 130. Now remember also that a central angle, this is a central angle because its vertex is the center of the circle. Central angle is equal to the arc that it creates. So that would make x 130. So x is 130. And if you want to write to central angle measure, is equal to arc. Okay, so that's one like that. That one has a little bit more involved, but it's pretty simple. Add in your radii, figure out the measure of that central angle by subtracting from 180, and then that's your answer because that's also the measure of the arc. Okay, so that's it on this section. Kind of a lot going on, but pretty easy once you do the practice. So if anyone has any questions, feel free to email me or join our help session at 11:30. All right, guys, have a great day.